The Magical Number of 7, presented by Lori Franks. Is the number 7 magical? One has to wonder. Look around the world and you see the power of the number 7. 7 wonders of the world, the 7 deadly sins, and the 7 seas. There are 7 continents and 7 days of the week, and throughout the Bible the number 7 is referenced many times. Is this just a coincidence, or is the number 7 really magical? George Miller wrote about the magical 7 plus or minus 2, and in his writings he posed some of the same questions. Let's take a further look into the number 7 and see how it relates to instructional design. Marie Dorey writes about Miller's life. George Miller graduated from the University of Alabama with a BA in History and Speech and a master's degree in speech. He went on to further his education at Harvard University, where he earned his PhD in psychology in 1946. By the 1960s, he had co-founded the Harvard Center for Cognitive Studies and was awarded the Outstanding Lifetime Contribution to Psychology Award from the American Psychological Association. Before we dig deep into the magical 7 plus or minus 2 theory, let's first look at what Miller said about communication. His work shows that the brain is an information processing machine. In order for communication to be effective, there must be a systematic relationship between what goes in and what comes out. Information processing dominates the field of cognitive psychology. It's important to look at the historical roots and evolution of any theory. Miller's theory is no exception. Miller's theory is supported by evidence from various studies. One particular study is the work of Joseph Jacobs. In 1887, Jacobs studied what he called prehension, where short-term memory was measured by the amount of numbers one could recall. His experiment focused on children. He found that older children could repeat longer strings of digits than younger students, and that it was easier to remember numbers rather than letters. Children could remember, on average, 7.3 letters and 9.3 numbers. This supports Miller's theory of 7 plus or minus 2. In Miller's 1954 research, he argued that if there is a small amount of input, then the accuracy recall would be high. But if the amount of input increases, the accuracy of recalling the information correctly decreases. He went on to say that the average memory span for accurately recalling information is on average 7 chunks, but could range anywhere from 5 to 9 chunks. Miller discussed 3 types of psychological tasks in which the number 7 has emerged. The first task was absolute judgment. In this task, a participant was presented with a single stimulus and its correct label had to be recalled. Miller presented lines with different lengths as well as tones with different frequencies. Participants could effectively and accurately identify an isolated stimulus when there were about 7 stimulus choices. The next task involved immediate memory. This task focused on remembering digit spans. This task involved digits and letters. He found people could successfully remember 7 plus or minus 2 digits, letters, or words. Badley's 1994 research goes on to explain that the concept of chunking developed based on this task. Incoming information is chunked and recoded. Badley argued that the process of memorization may be the formation of chunks. Let's clarify absolute judgment and immediate memory. Think about the game Simon. The device has 4 colors and each color is associated with a distinct tone. A player is demonstrating absolute judgment when distinguishing between the tones. The number of tones is set at 4. So based on Miller's magic number 7 plus or minus 2 theory, there should be no mistakes. Simon's increasing sequence length, however, is meant to push immediate memory capacity. Based on Miller's theory, one would expect it to be difficult to repeat back more than 9 tones. The last task is span of attention. The task had a set of haphazardly arranged dots. Participants were not given a large amount of time and had to enumerate the objects into sets. This task required participants to organize the dots quickly and remember how the dots were organized. Miller found people could remember about 7 objects in the collection. The concept of subitizing, which will be discussed later, emerged from this task. Let's go back now and further discuss chunking, which emerged from the immediate memory task. Cohen expanded on Miller's concept of chunking. He goes on to explain that people chunk units of information. Based on Miller's work, a person can remember about 7 familiar chunks. This isn't necessarily just 7 digits or numbers, but rather 7 chunks of approximately 3 or 4 units of information. This concept Cohen, Mori, and Chen would argue is Miller's greatest contribution to the field of cognitive psychology. Let's look at an example of chunking. Here we see a string of letters. A person could chunk this into 3 chunks: FBI, CIA, and USA. Based on Miller's theory, a person is likely to be able to accurately recall this string of letters by chunking the material into 3 separate chunks. In Cohen, Mori, and Chen's research, they cited 2 studies that support Miller's theory. The first study cited is Tullivan and Pacu. These researchers found people could remember somewhere between 4 to 6 chunks. A second study cited in their research is how Anders Ericsson and his colleagues trained an individual for months in hopes of increasing the individual's digit memory span. Even after intense training, the individual could only successfully remember about 7 chunks. Miller's theory directly impacts instructional design. The first impact his theory has had on instructional design is the concept of chunking. A close examination shows how chunking is critical in developing reading curriculum, especially in the elementary grades. Zing's research found that chunking material when reading improves comprehension. Furthermore, he found good readers chunk on average about 7 words when reading a sentence. Chunking words into phrases increases the reader's fluency rate, and chunking material helps proficient readers organize material. The second impact his theory has had on instructional design is the concept of subitizing. Subitizing is an important strategy to implement when developing the math curriculum for the primary grades. Clements and Bobbis' research supports Miller's concept of subitizing. Subitizing is important in the early years because it aids children in developing number sense, developing abstract numbers, and arithmetic strategies. With every theory, there is always criticism. Chen and Cowan found that not all researchers agree 7 was the magical number. Their research highlighted 3 different studies. These studies estimated that the immediate memory span was more likely to be 4 chunks, 3 chunks, and 2 chunks. Even with these criticisms, Miller's theory still continues to impact instructional design in today's classroom.